Hi guys, it's Gordon at Kaizen Active here, and this video is to explain the link between blood sugar and fat burning, and therefore how to turn fat burning up. So let's get to it. So basic diagram, we've got a muscle cell over in blue, a blood vessel kind of in red, and a fat cell over to the right in brown. So the first thing we're going to do is we're going to eat some carbohydrates and see what happens. Eating carbohydrates is going to put blood sugar, these little red dots, into kind of circulation. And if we eat more carbohydrates, if we eat a bigger meal with more carbohydrates, then we would have a greater kind of level of carbohydrates in the bloodstream. So what do we want to happen to that? Ideally, we would like the energy into the muscle cells. So when we eat kind of food, the idea is that kind of the energy that we eat kind of fuels the muscles and then is available for our use. However, when we eat lots of food, and particularly in this example, lots of carbohydrates, we get high concentrations of blood sugar. High concentrations of blood sugar is bad for the body. It can't leave it there. It's toxic to the surrounding cells. So it has to haul it out, and it hauls out the extra that it can't get into the muscles into the fat cells. So let's kind of have a little bit of a kind of chat through this. Muscle cells have got limited storage. Let's just talk about what that means when we're kind of eating, for example, like portion sizes. A typical man, kind of someone a little bit bigger than me because I'm only little, but a typical man might be able to store somewhere in the region of 2,500 calories in total in carbohydrates. Maybe, let's just keep it simple. Let's say 2,500 in the muscles. It's not normally as much as that, but let's say it is. So let's say he's already at 2,000 calories in the muscles. He can only store 2,500 in total. That means he can only get an extra 500 in here. So if this represents 1,000 calories, only 500 can go in here, and the remaining 500 can go in here. If you're a female, you can store less. So let's just say in this example, you can maybe store 1,800. If you're already running a storage of, say, 1,500, then you've only got scope for maybe 300 more. If this was 1,000 calories, 300 can go in here. The other 700 have to go in here. Another thing to kind of mention, just look at these little entry points on the cell membrane. There's only so many of them. And what that means is the rate the energy can move from the bloodstream into the muscle is limited. And a really kind of easy way of kind of thinking about this is, imagine this a whole lot of people queuing for that are inside a concert, and then there's a fire. Only so many can get out here or into the muscle cell, so the majority have to then leave by the fire escape, and that would be into the fat cells. So this rate limiting factor into muscle cells really affects, when you eat large portion sizes, what your body can do with it. Only so much, even if there's loads of space, only so much can get in here, and the rest has to end up in the fat cells. So once it's in the fat cells, the energy from here gets stored in here, and basically the blood sugar kind of gets stored as triglycerides, which is another name for fat cell. And these triglycerides have chemical bonds, so they're complex molecules. Now, why that's important is, what we're interested in when we're looking at kind of reducing kind of body fat is we need to get the fat out of the fat cells into the bloodstream, and then kind of off to the muscles to get used, if you like. So how do we get the fat out of, so how do we get the fat out of the fat cell? Well, the body won't break these chemical bonds unless it needs to. So let me make that kind of, maybe explain that a little bit better. To break chemical bonds is a really energy intensive process, and the body does not start a process that it doesn't need the end product of. If we started lots of processes that were just going to burn off extra energy, we wouldn't have survived, we wouldn't have evolved. So the body actually is designed to conserve energy. As you see it doing really nicely here, it takes blood sugar and kind of whatever it doesn't need, it stores as fat. Once it's in there, it's not giving it up unless it needs to. So let's kind of have a little look. What we want, of course, is we want this blood sugar, or rather, sorry, we want this fat coming out and being used. But it's not going to do it unless it needs to do it. So as you can see, I've drawn on these little, they're meant to look like satellite dishes called receptors. And in essence, what they're doing is the fat cell is listening for a signal to be told what to do. Fat cell wants to know, am I meant to be storing fat? Should I be breaking these bonds and giving energy out? Should I just be kind of largely staying still? What should I be doing? So these receptors are listening for something. They're listening for a signal to be told what to do. Cells are signaled by neurotransmitters or hormones, and the one that kind of is really important here, most of you will have heard of. So insulin is a hormone that fat cells listen out for to be told whether they should be breaking these chemical bonds or not. Think of insulin a little bit like a transporter for sugar, and what it's going to do is it's going to facilitate kind of movement into muscle cells and into fat cells. When there's high blood sugar, in fact, hang on a wee second. When we've got high blood sugar, then we're going to have high insulin. And high insulin, as you can see down here, it equals low or no fat burning. So when the body knows it's got energy in, it doesn't need to be kind of breaking these bonds and kind of putting more energy into the system, because actually it's got plenty of energy, and instead it's going to actually store. So high levels of blood sugar, as we can see here, is going to equal high levels of insulin, our hormone here, which is going to turn down fat burning or turn it off, and indeed facilitate fat storage. So there's our problem with high levels of kind of carbohydrates in the diet, or really high levels of blood sugar as opposed to high levels of carbohydrates in the diet. What we want is to have lower levels of carbohydrates. So as you can see, I just kind of took out some of the blood sugar, and when you've got lower levels, then it doesn't need to filter into the fat cells, because actually it can go into the muscle cells. I think what the other thing that I wanted to say is lower levels of carbohydrate in the bloodstream, low blood sugar. I say carbohydrate in the bloodstream, sugar in the blood, or blood sugar, is going to equal low insulin, and low insulin is going to kind of then turn up fat burning. So chemical bonds are going to get broken, as we should see in the next slide, I think. Yeah, chemical bonds are going to get broken, and this energy is going to be able to get out, which is exactly what we want. So hopefully that kind of lets you see that high blood sugar is linked to high levels of insulin. High levels of insulin, the fat cells are listening for it, and they'll turn their fat burning down. So we want, maybe I need to go the right way. So we want lower levels of blood sugar for maximum kind of fat burning effect. All right, one more thing just to cover. This diagram now, I want you to kind of think about immediately after exercise. Immediately after exercise, we can have high levels of blood sugar, and it's absolutely fine. Because if you look on this kind of cell membrane here, what we can see is now we've got lots of think of them like little doors, little entry points. After exercise, a hormonal cascade takes place, which in essence brings these extra little doors to the surface, and it allows, instead of the blood sugar all going over into here, now we can get almost all of it back into the muscles. Exercise is going to deplete the storage, deplete how much energy you've got in the muscles, so down it will go. So think we've only got this left, so we've got loads of room, and then these high levels of sugar with all these doors allow energy into the muscle cells without worrying about it going into the fat cells for storage. So immediately after exercise, you do want to be eating carbohydrates. You want to eat simple carbohydrates, things that many people avoid a lot of the time. So pasta, rice, potatoes, bread, all of that. Fruit, of course, absolutely great after exercise, because it's only going to top your muscle cells back up, and that's a good thing. So I hope this video has kind of made some sense for you. If you've got any questions, then just ask. Otherwise, thank you very much, and bye-bye.